Today's question is about solving logarithmic equations. Find y given that 6 log y base 2 plus log 2 base y is equal to log 1 over 32 base 2. First, we'll note that logarithm of y to base 2 is the reciprocal of logarithm of 2 to base y. We can note here that y and the base 2 have just switched positions. We can see that in this equation here, logarithm of y base 2 and logarithm of 2 base y. This is the reciprocal of this. We are going to solve this equation here by substitution. We are going to let logarithm of y base 2 be some letter, say t. So let logarithm of y base 2 be t. Now we are going to rewrite this equation using this. So we have 6t plus, now logarithm of 2 base y is reciprocal of t, so we are going to have 1 over t, and then we equate it to the right hand side. We have logarithm to base 2 of 1 over 32. 32 factorized is 2 raised to 5, 1 over 2 raised to power 5. Now 1 over 2 raised to power 5 can also be expressed as follows. So rewriting the equation, the left hand side becomes that, and the right hand side will have logarithm to base 2 of 2 raised to negative 5. 1 over 2 raised to 5 is 2 raised to power negative 5. The negative implies reciprocal. At this point, applying the laws of logarithm, the power negative 5 will drop before logarithm of 2 to base 2, so that this equation will be rewritten as 6t plus 1 over t for the left hand side, and right hand side negative 5 log 2 base 2. So the negative 5 has come before log 2 base 2. And from here, we'll be required to recall again logarithm of a to base a is equal to 1. The number a and the base are equal. If that is the case, the result will always be 1. So we can see that here, logarithm of 2 to base 2. So this part here is 1. So for the right hand side, it's equivalent to having negative 5 times 1. This equation can be rewritten as 6t plus 1 over t is equal to negative 5. Now, in order to eliminate this fraction here, we'll multiply everything by t. We multiply by t, and when we multiply, we're going to have 6t squared plus 1 is equal to negative 5t. Rearranging this equation, we'll have 6t squared plus 5t plus 1 is equal to 0. That is when negative 5t comes to this other side. Okay, so here we have a quadratic equation to solve, and I'm going to apply the factor method. So we're going to look for two factors or two numbers such that their product is equivalent to the product of coefficient of t squared here, that is 6, and the constant term 1. So 6 times 1 is 6. So the product of the two numbers is 6, and the sum of the numbers is 5. That is the coefficient of t, the middle term here. Now, the two numbers that satisfy this condition are 2 and 3. Multiply 2 by 3, you get 6. Add 2 to 3, you get 5. We are going to use these factors here to split the middle part. So rewriting this equation, we'll say 6t squared, and then for the middle part, instead of 5t, we are going to have 2t plus 3t. So plus 2t plus 3t, and then we add to 1, and then finally equate to 0. Now this will help us factorize by pairing. When you take these first two terms and the last two terms, pair them and factorize. So for this part, the common factor is 2t. So factor out 2t. We'll have 2t into 3t plus 1. And then for the next part, the common factor here is 1. So factor out 1. We'll have plus 1 into 3t plus 1. And then we equate to 0. Now 3t plus 1 is common to both this term and this term. So we factor it out. So we say 3t plus 1 into 2t plus 1. That is 2t plus 1. And then equate to 0. At this point, we can say 3t plus 1 is equal to 0. So 3t plus 1 is equal to 0. And that means that t is negative a third. Now at this point, we'll come back to the point where we had let. Remember, we had let log y to base 2 to be t. So this will resurface here. So instead of t, we will write log y to base 2. So log y to base 2 is negative a third. Expressing this in index form, we'll have the base raised to the number negative a third, giving us y. So y is equal to 2 raised to negative a third. So that we have y is equal to 2 raised to negative a third. And that is the value of y. The same can apply to this other part. So the next solution, we have 2t plus 1 is equal to 0. So 2t plus 1 is 0. That means t is negative a half. Again, coming back to this point, t is log y base 2. And therefore log y base 2 is equal to negative a half. This in index form is 2 raised to power negative a half is equal to y. So we say y is equal to 2 raised to power negative a half. Now already these are the solutions to the problem, but still we can express these solutions further in third form. Note that considering the first solution, if we're given y is equal to 2 raised to power negative a third, the negative here implies reciprocal, so that we can express this as the reciprocal of 2, which is a half, and then the power becomes positive, so that we have positive a third. And a number raised to a third is equivalent to finding the cube root of that number. So we're going to have the cube root of the numerator over the cube root of the denominator. That is cube root of 1 over cube root of 2. And that finally simplifies to 1 over cube root of 2. Remember, cube root of 1 is 1. So the numerator remains as 1. And then the denominator is cube root of 2. Similarly, when you apply that to the second solution, we have y is equal to 2 raised to power negative a half. Now, this can be expressed as 1 over 2 raised to power a half. Once again, the negative implies reciprocal. So we get the reciprocal of 2, which is a half, and then the power becomes positive. So a number raised to a half is equivalent to finding the square root of that number. So we are going to have the square root of the numerator over the square root of the denominator. So we have root 1 over root 2. So y becomes 1 over root 2. The square root of 1 is 1, and therefore we have 1 over root 2. And finally, this and this are the solutions to the problem as expressed in third form. Thank you for watching.